solve the equal equation. So that means we're going after the x-intercepts. That's where the numerator, x minus 3 times x plus 2 equals 0. And by the way, I need to make a note to myself. I want y negative or equal to 0. That means on this equal equation, these are all going to be solid dots on the number line. So this says that x equal 3, x equal negative 2. So I've got two critical numbers, 3 and negative 2. The not equal are the domain restrictions. That's where the denominator can't equal 0 or x can't equal 1. And by the way, these x-intercepts are multiplicity what? 1, so we have a change there. And this asymptote is multiplicity what? 1, because it's x minus 1 to the 1 power, so it's multiplicity 1. So you have a change there. So it's going to alternate. So I've got 3 critical numbers. So on the number line, I put my numbers. The x-intercepts, or from the equal equation, they're solid dots. So I have a solid dot at negative 2. I have a solid dot at positive 3. They're both multiplicity 1, so the y values will change sign because the graph will cross. And at 1, I have a VA. And that's an open dot because it does not include. And it's also multiplicity 1, so that means the arrows go in opposite directions. And now I pull a test point. My favorite is available to me. The hardest time, by the way, I have with test points, especially if I don't pull one at the end, like if I would pull a 4, I would be fine. Pulling 0, I need to make sure I've got the 0 in the right place. It's because 0 is between negative 2 and 1, I hope. Otherwise, everything's going to be skewed. Now, if you want to not make that mistake, always then pull a test point to the farthest right. And then it flips like a set of dominoes, and you won't make that mistake. But I do make that mistake periodically. So if x equals 0, I'm going to have 0 minus 3 times 0 plus 2 over 0 minus 1, which is minus 3 times 2 over minus 1, which is minus 6 over minus 1. Minus divided by a minus is a plus. This sucker's positive. So positive, change, negative, change, negative, change, positive, and I want negative. So any place this guy is negative is what I want. Now, because my open and my solid dots basically tell me whether I include or exclude, this then goes from minus infinity to negative 2, include, union not include 1, 3, include. And that's your answer. Yes, I'm right.
VA is not always an open dot, or is it?
VA is always an open dot because it's a domain exclusion.
That's what I thought.
Yeah. So it's a domain exclusion, so it's always open. You can become very fast at these.